as we said yesterday, we're talking about points, lines, planes, and space. What this is all about, guys, is, I gave you that example yesterday of like a definition, right? If I'm looking up a vocabulary word because I don't know what it is, and I read the definition, but inside that definition, there are maybe 3 or 4 other words that I don't know. I got to go look those words up, and I keep playing that game of looking up words that I don't know until I know every word in that original definition, right? Because now I can identify what that original vocabulary word was, and now I can use that to my benefit. In order to do that, we need some things to be what we call undefined terms, okay? Basically meaning we got to have a starting point. Does that make sense? Okay, if I'm going to build a house, Joel, you ever build a house with your dad? Yeah. So you need some starting points, right? You need a foundation, correct? Okay, a good foundation makes the rest of the house good, okay? So in geometry, we have a handful of terms that essentially don't have a definition. We can talk about them, we can kind of identify them, talk about properties of them, but they don't really have a definition because there's no geometry or no math before them. Does that make sense? That they can be based off of. So we start with these foundational ideas, and then we can use those to build new things. Okay? So that's kind of what this first couple sections is about, is discussing what we call our undefined terms. Okay? So yes, we talk about points. Okay? A point is location in space. So this is not necessarily, I know it looks like a definition, okay, but these are just descriptors of what a point is, okay, not necessarily in stone definition, okay, but it's a point, or a point is a location in space, has no size, and we represent it with a dot, okay. Now when we do this like on our own paper, you guys remember last year in algebra, if you were plotting points on the x and y axes, you just made a small dot, right? You're not making size quarter or something like that, okay? So small dot, the smaller essentially the better, because of the idea that the point should have no size. Use a point or a dot, capital letter to identify it, and then we have points A, B, and C. Okay, does anybody have questions over that? Talked about that a little bit yesterday. Space is the collection or set of all points. So if I were to round up all the points that ever exist, okay, and group them, we group them in what we call space. And we're going to just, right now, think about space as the space that you are aware of, okay? Right now, we are in space, correct? Okay? As I move around, I'm moving around in space, and I'm moving through locations of other things, okay? Kind of mentioned this, all other geometric figures are made from an infinite set of points, okay? So this is, I think, where we ended yesterday. I just want to bring this idea back to you here. If we put a point there and there, okay? So those are just 2 points, 2 locations in space, okay? Now, right now, because I'm on this plane, we call it 2-dimensional space, okay? So when I talk about dimensions, guys, for us, there are things that are called like 1 dimension. 1 dimension is like a line, okay? Only goes one left or right. Does that kind of make sense? Left or right, 1 dimension, okay? Or up and down, or like northeast to southwest, something like that. 1 direction. So when I talk, really, when we say dimension, we're thinking kind of directional abilities or capabilities for that shape, okay? Points are actually identified as having 0 dimension. Lines are 1 dimension, okay? Now, if I look at that yellow grid up there, if you're moving in that grid, can you go left, right, up, and down? So the left and right is considered 1 dimension, and the up and down then is considered a 2nd dimension. So that's 2-dimensional, we call it a plane, okay? If we were able to move left, right, up, down, forwards and backwards, so now forwards and backwards provides what we call depth, That would be our third dimension, right? Does that make sense? Okay. Everything that we're doing early on in this course is going to be two-dimensional, okay? There will be some three-dimensional ideas when we talk about planes and looking at planes, but three dimensions comes into play in like chapters 12 and 13 or 11 and 12, something like that, okay? So right now inside, but every two-dimensional surface is part of space. Does that make sense? Okay. So I've got points A and B here, and we talked yesterday, I can highlight another point between them, okay, but I still just have a bunch of kind of independent locations here being identified. I can zoom in and I can put points in between wherever there are gaps. I'm just going to zoom in so I can get these just easier to put on these crossings of the grid lines. But I can keep doing that, right? And then there's a lot of different spots in here just trying to fill in the gaps. And then if we I'll just get rid of the letters here and zoom back out, if I highlight enough, they start to look like they merge together, right? Now there's still an infinite number of points in between any two of those points I choose, but the more I highlight, it starts to look like a segment, right? Okay. So every time I look at a segment, so maybe we got this segment here, and I ask you how many points are up there, we see two of them being identified, right? T and U are being named, but there's an infinite number of points between T and U. Does that make sense? Okay. So that's something to keep in mind as we move through the course. When I ask how many points there are, something like that, it's usually there's an infinite number. Okay, how many points are being identified then are two, or how many are being labeled? That'd be two. Okay. I think that's kind of where we stopped yesterday, right? All right, so this is we mentioned this yesterday, and we started talking about points, but a lot of early on, so especially when it's something that is maybe a new shape to us or a new concept, we'll spend time talking about how do we write that in math notation or geometry notation, okay? Because if I'm going to read a geometry text, I'm going to look in Math Excel, do a homework assignment, and they provide something notation-wise that I can't read, I'm really not going to be able to perform on that question. Okay, I get to the end of course exam, or I get to the ACT, and they use a notation that I'm unfamiliar with, probably not be very successful in that question. Okay, so as we move through, we will talk in depth about notation. That's one of the things, just in my experience as entering like a college math course, my first time. Like I was in school, when I was in high school, I was a good math student. I had A's through high school math. But when I entered college, I started to realize some of the things some of my practices in high school weren't really helping me in college because I didn't know the notation as well as I should have. And if I was going to read a text in college, then I was only getting about 2/3 of the information because I didn't know all the notations. Does that make sense? And then I had to take the time on my own to investigate what that notation meant, to learn it, relearn it, and once I did that, it made things so much easier. Okay, so we're going to spend quite a bit of time on notation, even when so if you're going to haphazardly learn the notation and use it correct half the time, you might write something down where you mean that you're going to write down a segment, or you're intending to write down a representation of a plane or something like that. But because you did it incorrectly, you wrote down something completely different, and you're representing a different object now. Does that make sense? So what the things that you're trying to convey are completely different than what you actually write. Okay, so your intentions are different than what happens. So we got to make sure, we got to be very cognizant, aware of that when we're dealing with labeling things and writing notations. Okay. So first thing here is talking about, this is another undefined term, okay? It's called, they're lines, okay? A line is a series of points that extends without end in two directions, okay? You're going to hear me talk all year long about how we use terminology in a mathematical setting and how we use terminology outside of math, because there are words that kind of overplay into both, okay? I'll use the word line in math, but I'll also go maybe to art class and we'll talk about a line out there. Or maybe we'll talk about when we line up in to get our temperatures in the morning, we're in a line, right? Okay. The way we interpret them, because we're in math, is a little bit different, okay? In art class, okay, they might say, you know, draw a line, and you take your pen or whatever medium you're using, and that might be a line in art. I just drew a line, right? Okay, that's not a line in mathematics. That's a curve in mathematics, okay? Or we say it's non-linear. By this statement up here, it says a line is a series of points that extends without end in two directions, okay? If we take that curve that I broke up and segment it, there are instances in where it's going more than two directions, okay? Basically what it means is the arrows on that image show that it's going on forever. We have to have this. If we don't have the arrows, we are inferring that it stops, okay? And that would be contradictory to what the statement says. A line is always straight, no bends, curves, or corners, okay? So in mathematics, if I ask, you know, what kind of line is that, and people say this all the time, they'll say it's a straight line. That's redundant, because by this statement here, lines have to be straight anyways. Does that make sense? Okay. So in math, lines never bend. There are no curves. There are no corners. There are no cusps. A cusp in mathematics is something like this. Like that little point right there is called a cusp. Okay. Those things don't exist in lines. There are no breaks, no gaps, no holes, nothing like that. Does that make sense? Okay. A couple different ways you can interpret or identify, I guess, a line. You're going to use 2 points that are on it, okay? So in this case, I've only shown points A and C, so I would use line AC, okay, or use those 2 points. And then I'm going to, above it, make my line segment image and put arrows on the end of it, and those arrows tell me it goes on forever, okay? If I don't put the arrows on it, I identify something completely different, okay? And we'll talk about that here in the next couple slides. They got to have those arrows on. Now, what I like to do is talk about the alternative ways of writing a line, okay? Because there's no specifics on what letters I had to choose there or the order that I had to choose. So it would have been okay to write that as line CA, okay? The reason I talk about this is if I put myself on A and walk to C, okay, now the idea is that I'd be able to walk even further to the left of A and further to the right of C. But if I go from A to C, do you have the exact same line as if you walk from C to A? Is it the same image? Yeah. So I always put myself kind of in the picture and ask myself, do I get something completely different, or do I get the same thing when I walk on that set of directions, essentially, okay? And for the same, that tells me I could have flip-flopped the answers, or not the answer, but the endpoints, and got the same line. The reason I talk about that is when we're doing work later on, and I say, you know, the answer needs to be AC, and inevitably somebody will say, I didn't get that, I got CA. That's okay. Does that make sense? It's nice that you can get multiple answers, and that's also kind of what stinks, because there will be times that I identify something one way, but there might be 15 different ways to identify it. Does that make sense? Okay. If there were other points on there, so let's just say somebody put like point B on here, and maybe point D. If I said line BD, so if I go from B and walk through D all the way to the right, or if I started from D and walked to B all the way to the left, if I walk that, is that the same thing as walking from A all the way through C to the right and C all the way through A to the left? It's the same line, right? So I might have named it BD, but all of you named it AC. but we're talking about the exact same image. Does that make sense? And that's kind of that tends to be a big problem later on, especially for people that can't justify it themselves. Okay, somebody calls it AB or AD or CB or CD. Those are all alternative ways. Okay, occasionally, just to make things easier, they will put like a lowercase letter next to the line. It's usually italicized or cursive, and we can call that line M. Okay. A lot of your pictures in Math Excel will do that, especially when we start talking about like 3, 4, 5 lines in the same picture. They'll call them like line L, line S, line T, that kind of stuff. Okay. So a lot of different ways we can name a line. Anybody have questions on that? Some of the stuff you've been aware of, right? Some of that stuff you already knew from the past. And that's the thing. That's kind of what stinks, I think, about geometry early on is you've been dealing hit and miss in like 5th grade, 6th grade, 7th grade, 8th grade with geometry concepts. But I don't want to just kind of start with like chapter 2, and some people have everything they needed from chapter 1, or there'd be 2 or 3 people that there's a handful of things in chapter 1 that they needed to talk about. Does that make sense? When I was in school, like day 1, my teacher gave us chapter 1 homework. He said, do chapter 1 tomorrow. We're starting chapter 2. Because of chapter 1 being a lot of terms and a lot of just procedural things for writing and identifying things. Okay. That turned out to be pretty ugly for some people because they didn't get everything they needed to. Okay. So we take a line, we can start breaking a line apart. Okay. We start chopping parts of it off. If I chop both ends of the line, I take 2 points, chop to the right of one point off, to the left of the other point off, we get what we call a segment. Okay. So this here would be a segment. AC is a segment. Okay. And the way that we're going to identify that, again, we're going to choose the endpoints. Now here, if there's another point on there, for instance, if I put this B down there, okay, the A and C tell me where I start and where I stop, okay? It was basically essentially a set of directions. If I start at A and I finish at C, does that trace out that segment right there? Start at A, go to C, right? Okay. If I start at C and go to A, C, finish at A, is it the same segment? Okay. Now I'm putting that segment image above. Okay. There's no arrows on that one. Okay. Sometimes you'll see textbooks actually be a little bit more like blatant about it, and they'll actually put the dots on the end. You don't have to. I never do. But here's where I can't use B, because if I go AB, is that a different segment than AC? Is it a different starting in any point? Yeah. Okay. So AB is a shorter segment. So there, when I name a segment, I have to use the endpoints. Okay. And again, no arrows on the graphic above the letters. Okay. AC are your endpoints. Okay. I think that's pretty self-explanatory. This one's kind of got a combination of the ways we've talked so far about naming things. Okay. If I just chop off one of the sides that extends forever, I get what we call a ray. Okay. A ray, the way you have to name that is you have to start with the endpoint. Okay. So if we chopped off that over there, this point A is the endpoint. Okay. There's nothing to the other side of it, right? Okay. So you have to start with that. And then as you move along the ray, you need to identify another point on there to basically tell the reader kind of the direction that you're moving. So I'm going to start at A, and my ray is going to move through to the direction of C. Okay, so I start at A, go through C. I draw my arrow above it. Okay, your arrow on a ray will always be pointing to the right when you name it. Okay. Something you cannot do. I cannot flip-flop them for array. If I do that, what point would that say I start with? C, and now I'd be moving left through A, right? That's a completely different array than starting in A and moving through C. So this does not work. So a lot of times we'll write like CA is not the same as, usually we say not congruent to like array AC. Okay. What if I put B in there? What if B showed up right there? Is ray AB the same as ray AC? Yes. Okay. So here's a situation where there is some criteria they have to meet, but there is also some freedom that is allowed when naming rays, because we can use multiple points to the right of A for my second letter in my name. Okay. We good with that? These are what we call opposite rays. It's kind of silly. I think it's a dumb definition, to be honest with you, but even though I think it's dumb, some of our other vocabulary words in the textbook use the word opposite rays in them, so we got to know what they are. And essentially what it is that we start with an endpoint. Two opposite rays are rays that share an endpoint. So here we got the red one and the blue one, right? They share endpoint R, okay? One is moving in a direction to the right, so RQ is going to the right. RM, that ray is going to the left. Right and left are opposite directions, right? Okay. Now they could be up and down. They could have slopes to them, all that kind of stuff. It's just easier to draw right and left. Okay. But those would be considered opposite rays. Collectively together, what do opposite rays make? They make a line, right? Okay. So that's going to be important in a few sections because of eventually we're going to put like a line or an array right there, and we'll talk about what kind of angles these are. But in that definition, it uses the phrase opposite rays. So if we name these, we'd say RQ and RM. Those are the ones that are opposite based off of the knowledge of just those 3 points being highlighted. If there was a 4th point up there, there would be a lot more options for opposite rays. Okay, and we'll get into seeing things like that later on. Take a minute just on your own on this next slide and just name that line at least 4 ways. Yeah, there may be more. When we have access to Math Excel, some of your questions will be like this. This is why this question's here. A lot of the examples I provide in the PowerPoints and the notes that we do together in class, they're going to model the homework questions. There'll be times that I ask you together to work on a problem with me. Might do 1 or 2 like that, and then I'll give you an opportunity to do one on your own and see what we come up with. sometimes people argue, well, line XB and line BX isn't a different name. I would consider it a different name. So what's going to happen in Math Excel is that they're going to give you a picture like this, and then underneath it there's going to be like 15 boxes that you can check, and it'll just say check the ones that are valid names for this line. So you would check XB and you would check BX. Does that make sense? Okay. Is that cool? We good with that? Okay. Stop me, guys, if I go too fast. Something doesn't make sense. You know, one thing that as a teacher that I have found that is beneficial to students, and I wish I would have been taught this way when I was in school, just in all my courses, is like techniques to remember something, or techniques to kind of ingrain something in my mind. Okay, if I look at vocabulary words in this class, most of them, if I don't know what the concept is, I don't know what the vocabulary word really says, but I'm able to look at like root words and prefixes and suffixes and understand adjectives and nouns and that kind of stuff, then I can probably decipher what my vocabulary word is. Okay, so when I look at this first one, okay, it says collinear points. Okay, what is the noun up there? Is collinear or is points the noun? What kind of object are we talking about? Talking about points, right? So this is a noun. Collinear then is a description of that noun, right? So what kind of like grammar word would that be? What are describers? Starts with an A. Adjectives, right? Okay, so collinear is an adjective. Now collinear has a prefix on it, co. What's co mean? Like if I have co-workers, or we do something cooperatively, or something like that, what does that mean? Together, right? Okay, so co means together. Now, looking at essentially the root word here is line, right? So when I say linear, I'm referring to a line. So we've got points, which is our noun, together on lines. Does that kind of make sense? If we look at the definition, it says two or more points that lie or exist on the same line. So collinear means that they are together on the same line. Okay? So points A, B, and C there would be collinear. Okay? You know, I could put I'll highlight as many points on here as I want. Like A, B, C, D, and E would be collinear, right? Now here's my question. Let's get rid of E and D. Let's put F right there. Okay. Would A, B, C, and F be collinear? Are they all on the same line? No. Okay. The only way that I can make A, B, C, and F fall on the same thing is if I took that line and I bent it, right? So that it falls down through F. Well, doesn't that contradict or go against what we said lines were allowed to do? So then it would no longer be a line, okay? So things that are not collinear, points that are not collinear, we call them non-collinear, okay? Non-collinear. Sometimes you'll see collinear with two L's. Sometimes you'll see it with one. But like I said, like A, B, C, D, E, the way I had that, those were all collinear. But then when I put F down there and I had to bend the line, now I violate the undefined term of a line, so it's not a set of collinear points. Okay? All right, so this next thing, I think, is the most abstract thing that people struggle with early on in geometry, and it's what a plane is. Okay? A plane, by definition, is a flat surface. So I always like to think about like taking a piece of paper. Okay? Just a singular piece of paper. So you can find one. There we go. And if I were able to keep it flat, so when I curve it like that, that's no longer a plane. Does that make sense? Okay? We call that, just in math, I would call that a surface. Okay? But if it's flat, okay, we can call it a plane. Now, the idea is that this thing goes on forever in that direction, goes on forever towards you, away from you, and then in that direction. Okay, so it extends in all directions forever. Now, usually, obviously, we can't draw that, so a lot of times it will just like draw the rectangle. Okay, but we have to interpret and understand that it's a plane, and it should extend in all directions forever. It is essentially, it's highlighting all the points that are kind of in that surface. Okay, and remember, points have no thickness, right? They have no size. So a plane has no size. It has no thickness. Okay, so even this, a piece of paper, very, very, very thin, right? But it still has thickness. Okay, a true plane would not have thickness. Okay, if we look at, see if we can see something here in GeoGebra real quick. I figured that would happen. So in order to like fully understand a plane, I think it makes sense to look at them in three-dimensional space. So I'll just look at this one right here. Let me pop it out. All right. My graphics card, for some reason, won't let GeoGebra open a three-dimensional shape in my GeoGebra applet. Okay, so I have to do it inside this, but it shouldn't be a big issue. So this rectangle here, okay, is a plane, and what we want to do is we want to envision that it's going on in all directions forever, that it's defined for. So it's not coming like this direction, it's not coming out this way, right? Okay, but like from here to there, I would then extend it that way forever, right? Does that make sense to everybody? Okay, from that point there down, I would extend that direction down forever. But that is a plane, and if I look at it, it's got no, try to look at it on that end, there's no thickness to it. There should be a point where if I can get my cursor, it completely disappears because there's no thickness to that plane, okay? We can do that. That's still a plane, okay? But they're always going to be flat and extend forever. When we name planes, you can use a couple different strategies here. You can use 3 points that are in that plane, and usually the way they draw them, they're going to be like the vertices or the corners of the rectangle. Sometimes they draw planes as triangles, but you need at least 3 points, okay? Or you can use a capital cursive letter. So I think I've got kind of a goofy picture next right here. So that's what I'm talking about. That's hard to recognize what a plane is, I think, in contrast to looking at GeoGebra and trying to learn what a plane is. I think GeoGebra gives you a better visual than that, right? But there are 3 points in that plane called E, Q, and T, so we call that plane EQT. Just put them in that order. And it doesn't matter the order. So somebody could have called it TQE, somebody could have called it QET or QTE. Okay, it doesn't matter. That all identifies the same plane. Okay, even, and here's what kind of stinks about this. And I'll do it in that GeoGebra, make it a little bit easier to view or understand. So let me refresh this, and we'll go back to the original. Okay, so that blue triangle, right? Everybody okay with that? if I extend that in all its directions, go down, go to the right, and then off that like hypotenuse or whatever, that third side, would that extend to encapsulate the same exact plane that if I extended the rectangle? Does that kind of make sense? They're going to overlap completely eventually, right? Does that make sense? If I extend them infinitely. So that idea is why we only need 3 points, okay? But if I have 2 points, that's just a segment now, right? So 3 points will identify the plane, okay? In your plane, using, points D, C, and whatever that point there is, let's call that point like F. If I use D, C, and F, that's the same plane as if somebody used A, D, and F. Or if somebody used A, C, and F. Does that make sense? Okay. There's usually an alternative way of writing something like this capital R, cursive R, to remove some of that ambiguity or vagueness or confusion when there's multiple ways of naming an object. Okay. Sometimes you'll see these dotted edges. Those dotted edges just tell you that we're anticipating that thing moving on forever in all directions. You guys crop pictures, right? Okay. When you crop a picture, are the edges dotted? Because you can expand, that's a plane, and you can expand that as far as you need or as small as you need to crop that picture. Okay, so going off of what we already know about collinear points and non-collinear points, what do you think coplanar points are? Is it Daxton? Is that right? Points that are in the same plane. Okay, points that are in the same plane, and you can say. So here's the idea. 3 points, no matter what, are always in the same plane. Okay. So Jagger, can you lift your hand up for me? Okay. Can you lift your hand up for me? And can you lift your hand up for me? Okay. Now, envision, guys, like a flat piece of, you guys know what plexiglass is, right? Okay. Take a flat piece of plexiglass. Can I lay that and touch all 3 of their hands? Would that work? Could that be something that could be done? Okay. Jagger, move your hand down lower. Okay. Can I still take the same piece of plexiglass and put it through their 3 hands? Does that make sense? Okay. If you've got 3 points, no matter what, you guys can change that. No matter what, there is a plane that will go through them. Okay. So 3 points are always coplanar. Now, if I put 4 points, you guys put your hands back up. Okay. Now, if I put my hand like up here, is there one flat piece of plexiglass that's going to touch all 4 of our hands? No, it'll touch 3 of them, but then we got to bend it to get to the other person's, right? And if we bend it, it's no longer a flat surface, so it's no longer a plane. Okay. So when we talk about coplanar points, we always start with 3 or more points that are in the same plane, because 2 are always in the same plane. 1 point can't be co with anything, right? But 3 are always in the same plane, so we always go 3 or more when we make the definition. Not a huge deal, but that's why we start with that number. Okay. Therefore, non-collinear points. I spelled points wrong there. Non-collinear points are just points that are not in the same plane. So that could be just looking at 2 different points. Could be looking at, a handful. But that's the idea of what that's using. So if I know what collinear means, I should automatically know 4 definitions then. If I know what collinear means, I know what non-collinear means by just negating it. And then using what I know about collinear, I can talk about what coplanar means. And if I negate it, I get my 4th vocabulary word. Does that make sense? So when I'm going through in our first test and we've got 30 vocabulary words, do I need to memorize all of them? That's not how I file things in my mind. I try to make relationships and say, instead of remembering 30 things, how can I develop relationships to where I can dwindle that 30 down to maybe like 5, but know like 4 relationships that bridge into those 30. Does that make sense? And it just makes things, I think, easier, especially in math when it's new to us, okay, or can be new to us. All right, let's stop there, okay? We don't have, like I said, we don't have Math Excel yet, so there's no need in finish this to get us to the homework. We'll pick this up tomorrow. Hopefully tomorrow we can, my hope is that those codes show up today, and then knock the rest of those slides out and maybe have some time to work on our homework. But tomorrow we talk about some key phrases called postulates that are going to be very, very beneficial for us to learn and understand, for us to work through the rest of geometry.